So this is the fourth installment of solving quadratics, and this is the last technique that we can use to solve them, and it is called the quadratic equation. At this time, I'm just going to give us the quadratic equation because we're going to do some problems in class, and we're going to talk about more in detail how this came about and where it comes from. But for right now, we're just going to be able to use it. So this is the x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now that just seems like a jumble of letters and things, but we use this for any quadratic in the form ax squared plus bx plus c is equal to 0. So some things to take note of, that in order to use the quadratic formula and to get the right sign, meaning whether it's positive or not negative of the numbers, it needs to be set equal to 0. Okay? So just like if I was going to factor it, I move all my terms to one side and I set it equal to 0. So you notice that these don't have any x's in them whatsoever. A, B, and C are just the coefficients of each thing, right? A is the leading coefficient because it's the constant term in front of the x squared. The b is just the coefficient of x, and c is the constant term, right? So if I just had 3x squared plus 9, right, I could also, it would just be that my b would be 0 in this case because my 9 would be the constant c. So I don't have to have all three. The only thing I have to have is that a cannot be 0. All right, so let's just use this for a second. We have x squared plus 4x equals 7. So the first thing that I notice here is that my quadratic is not in this form. So that's the first thing that I want to do, is move the 7 so that it's on the left-hand side, and then I have 0 on the right-hand side. So I have x squared plus 4x. I'm going to subtract 7 from both sides here. And then I have minus 7 over here, and I end up with 0 over here. Okay? So now I'm going to carefully define my a, b, and c. So I have, in this case, right, the a is implied that it's 1. We don't usually write 1 when it's a coefficient, so we have to assume, really, that it's 1. It's implied. So a is 1, b is 4, and c is negative 7. So we keep the sign that's in front of this, each one of the coefficients. Okay. So now I have x is equal to negative b, so b is positive 4, so I have negative 4 plus or minus the square root of 4 squared, that's b, minus 4 times a is 1 times c is negative 7 all over 2a, which is 2 times 1. That leaves me with x equals negative 4 plus or minus the square root of 16. And then I have negative 4 times 1, really I have minus, right? 4 times 1, which is 4, times negative 7, which is negative 28. So I have negative minus negative 28, which gives me actually plus 28 over 2. Okay? So I end up with x is equal to negative 4 plus or minus. Now I can add these two things together, and that gives me 44 over 2. Now my radical can simplify a little bit, but in this particular case it's really not a big deal, so we're just going to leave it as it is. Okay? So this again gives me two solutions, right? I could break them apart and write them as x is equal to negative 4 plus the square root of 44 over 2, and x equals negative 4 minus the square root of 44 over 2. Okay? So in some cases, you might be tempted to simplify a little bit here, and if we simplified our radical, which really isn't necessary, we could simplify it, but we never ever want to just simplify these two things together because I have a plus and a minus between these two, okay? So I never want to simplify them because this 2 is divided by both of these things, not just one. So it's just best if you leave it as it is. So let's do another example. This is an example. I got two solutions. Right? Quadratics, I've said before, you can possibly have 0, 1, or 2 solutions. Right? Most of the cases that we've worked with so far have had 2 solutions, and so did that one. So let us look at this next one, and we're going to use the quadratic formula again. I have x squared minus 6x plus 9 is equal to 0, and we want to use the quadratic formula. So again, this is in my ax squared plus bx plus c form, so this is good. So my a, again, is implied. It's the 1 because there's nothing written in front of x squared, so we assume that the 1, it's 1. My b is negative 6, and my c is 9. So using my quadratic formula, I get x equals negative b. So this time b is already negative, so when I apply a negative 6, that gives me a positive 6, plus or minus the square root of negative 6 quantity squared minus 4, because that's my b squared, times a, which is 1, times c, which is 9, all over 2 times a, which is 1. All right, so now I have some simplifying to do. X equals 6 plus or minus the square root. Negative 6 quantity squared is 36. Right? Whenever you're plugging in numbers into something, you always think of it in terms of parentheses. So negative 6 quantity squared is going to be positive 36. This b squared will always be positive. And then I have minus 4 times 1 is 4 times 9 is 36 over 2. Right? So I have x equals 6 plus or minus basically 0, right? The square root of 0 is 0. And so I have really 6 plus or minus 0 over 2, which means really I have x equals 6 over 2, which is 3. So this time I just got one solution. Okay, so this is an example of a one solution case. So let's look at one more case. I have x squared plus x plus 1 is equal to 0. It's in my ax squared plus bx plus c form. So in this case, my a, b, and c are all 1. So a equals b equals c equals 1. So this should be quite easy to put it in my formula, right? So I have negative b, which is negative 1, plus or minus the square root of b squared, which is 1 squared, minus 4 times 1 over 2 times 1. So I have x equals negative 1 plus or minus the square root of really 1 minus 4 over 2. So I end up with negative 1 plus or minus the square root of negative 3 over 2, which is not a solution at all, right? Because this does not exist in the real number system. So this one is a no solution case. We can't take the square root of a negative number because it just doesn't work that way, right? When I square negative 3, I always get a positive number. When I square positive 3, I still get a positive number. So to undo it, I'm never going to get a negative number underneath that radical sign. So this is a no solution case. Which brings me to the idea of what we call the discriminant. If you noticed, right, let's bring this back here for a second. Here's my previous example. When I got a two solution case, if you notice, right, I got a number underneath this radical, a positive number. That gave me two solutions because I have a number plus or minus the radical over 2. So this was my two solution case. Here was my one solution case, right? So my one solution case, I ended up with 0 under the radical. So when I have 6 plus or minus 0, really that's the same thing, right? 6 plus 0 and 6 minus 0 are exactly the same thing. So when I end up with 0 underneath the radical, that's an indicator I'm going to get one solution. And then finally, in our last case, you might notice that I ended up with a negative number under my square root, and that is a no solution case. So we can actually think of, right, this square root of b squared minus 4ac, this is the thing that tells us about how many solutions my quadratic is going to have, right? We usually call b squared minus 4ac, this is called the discriminant. Okay? And so kind of to summarize what I just said, when b squared minus 4ac is greater than 0, right? That was when we got the square root of 44. Then we get two solutions. when I got b squared minus 4ac was equal to 0, right? Then I get the plus and minus 0 and I get the exact same solution twice. That gave me one solution. And when b squared minus 4ac was less than 0, I got that negative radical 3, right? Then I had 0 solutions. So if you're looking to check really quickly for whether or not your quadratic has a real solution, then this is one way to do it. Is just to pop those numbers into this what we call the discriminant, which is that piece that's underneath the radical, and it can very quickly, with a little algebra, you can tell how many solutions you can have. All right, that ends our discussion for this video.